Let me ask you one simple question. When you unlocked your phone today morning, did you think about cryptography? Probably not. What about when you opened your WhatsApp, checked your email, logged into your bank account, or bought something online? Again, probably not. But cryptography was working in the background during all these activities. It was helping you to protect your password, your messages, your payment details, and the connection between your device and the services you were using. Now, as soon as I say career in cryptography, some of you may be thinking, Heyman, this sounds very mathematical. This is probably not for me. But just stay with me, because that is only one part of this field. You can build a career around cryptography without sitting all day solving complicated mathematical equations. So in this video, let us understand what people in this field actually do, the different types of roles available, and how you can start preparing for them. Hello everyone, I'm Hemant and welcome to your Cyberstop. This is another video in my Cybersecurity career options series, where I explain different career options in cybersecurity in simple and practical language. Stay until the end, because I'll tell you how one code letter played a part in the downfall of a queen. So today we are looking at cryptography and communication security. Now let us first understand what that actually means. Suppose you are sending someone a message saying, let's meet at 5. Now that message has to travel from your phone through different networks, system before reaching the other person. If it travels as a normal readable text, someone who intercepts it may be able to read it. Now encryption changes that readable message into something that looks meaningless. Now the intended recipient can change it back to the original message by using some method. But protecting the content is not enough. You also want to know that you are communicating with the right person or the right services. And you want to know that nobody changed that message while it was traveling. This is where your encryption, hashing, digital signatures, and digital certificates come into picture. You do not need to understand every technical detail right now. The main point is that cryptography helps us understand 3 questions. Can someone else read this information? Has anyone changed it? And third, am I communicating with the genuine person or system? That is why cryptography is almost used everywhere, including your banking, your messaging, online shopping, cloud services, mobile application, government system, and connected devices. Now there are 2 closely related sides to this career. The first is cryptography itself. This involves studying algorithm, analyzing whether they are secure, and sometimes developing new cryptographic methods. Now the second is communication security. Here you are normally taking established cryptographic technologies and using them to protect a real system or a communication services. Now one person may help design or test the lock, the other person makes sure the current lock is installed, the keys are protected, and everything continues to work. Now both roles are important, but they require slightly different skills. So the next question is, what are the possible career direction? I would divide the career opportunities into 3 broad areas. The first is cryptographic research. This is the area most people imagine when they hear the word cryptography. Researchers study algorithms, they look for weaknesses and explore new methods of protecting information. If you enjoy mathematics, computer science, research and solving complex problems, this may suit you. For advanced research positions, a specialized master's degree or a PhD may be required. Now the second area is cryptographic engineering. A cryptographic engineer does not necessarily create a new algorithm. They take trusted algorithms and safely build them into software, hardware, and cloud platform. For example, they may work with secure software libraries, hardware security modules, digital signatures, secure boot, or cloud key management services. The third is PKI, Key Management and Communication Security Operations. Now PKI stands for Public Key Infrastructure. People working in this area manage digital certificates and cryptographic keys. They make sure certificates are issued to the correct system, renewed before they expire, and revoke when they are no longer trusted. So think about this as 3 different options. Research the technology, build the technology into products, and third, operate and manage it securely. Now which one sounds more interesting to you? Now let us look at what the actual work could involve. You may discover that a digital certificate used by an important application is about to expire. Now if it is not renewed in time, users may suddenly be unable to access that application. And certificates have a habit of expiring at the most inconvenient time. You may review a cloud system and check who can access its encryption keys. You may help a developer select the correct cryptographic library instead of creating their own encryption method. You could investigate why two systems are unable to establish a secure connection. Or you may support the replacement of compromised key and identity every application that was using it. In more specialized roles, you could test algorithms, examine weaknesses in security protocols, or work on technology designed to resist future quantum computing attacks. Now, if you want to design and analyze cryptographic algorithms, then yes, you will need a strong mathematical background. There is no point in pretending otherwise. But if you want to work with PKI, digital certificates, key management system, TLS or cloud encryption, advanced mathematics is normally not the main requirement. You need to understand how cryptography works, where it should be used and what can be wrong. For example, you should understand the difference between encryption and hashing. Now here's a quick question. Should a password normally be encrypted or hashed? Now it should normally be protected using suitable password hashing method. The system needs to verify your password. It should not need to recover and read the original password. If you did not know that, no problem. That is exactly the type of concept you can start learning. Now who will enjoy this field? Now this career may suit you if you like logical problems and enjoy understanding how things work behind the scenes. You also need to be patient and methodical. A small mistake in key management or a missed certificate renewal can create a major security incident or service outage. You should be comfortable following standards because this is not an area where we should experiment with our own homemade encryption. You also need good communication skills. You may understand the technology, but you still have to explain the risk and solution to developers, architects, managers, and sometimes customers. So how to start? If you are interested, where should you begin? Start by learning the basic concepts. Understand symmetric and asymmetric encryption, hashing, digital signatures, certificates, PKI, TLS, and cryptographic key lifecycle. Now do not try to learn everything in 1 week. Take one concept, understand why it exists, and then try to solve yourself. You can open the certificate information for any secure website in your browser. Look at who issued the certificate, which website it belongs to, and when it expires. You can use OpenSSL in a safe lab to create key pair, issue a test certificate, encrypt a file, and verify a digital signature. If you are learning cloud security, explore the key management services provided by a chosen cloud platform. Create a test key, give access to a test application, enable logging, and then practice rotating the key. Now you are not building a production banking system, you are simply learning what each component does. You can then turn into a portfolio project, document what you have built, draw a simple architecture diagram and explain how you protected the keys. Now if you're already working in IT, use your current experience. A network engineer can move towards TLS, VPNs or certificate-based authentication. A cloud engineer can learn key management, secret management and hardware security models. An IM professional can learn certificate-based authentication and PKI. A software developer can focus on secure implementation of cryptographic libraries. You may already be closer to this career than you think. Now let's talk about qualification and job searches. For research-focused roles, a degree in mathematics, computer science or related subjects can be very useful. For engineering and operational roles, practical experience in your networking, Linux, cloud, software or cybersecurity can be equally valuable. Security and cloud certification can support your learning, but certification alone will not make someone a cryptography specialist. Now, many cryptography related jobs sit under wider engineering or cybersecurity titles. Your salary will vary significantly by country, your sector, experience and type of role you are applying for. Specialist roles may pay well, but focus first on developing useful skills rather than following that salary. Now, why this field is becoming more important? So there is one more reason this area is receiving attention: quantum computing. It may eventually be able to break some of the public key cryptography we use. So does that mean our current encryption will suddenly stop working tomorrow? No. Does it mean organization can ignore the problem of quantum computing for another 10 years? Also no. So new post-quantum cryptography standards are already available and large organizations are beginning to identify where cryptography is being used across their systems. They will need people who understand certificates, keys, application, networks, and cryptographic migration. Most organizations will not develop their own quantum resistant algorithm. They will need professionals who can safely introduce approved technology into real environments. And that is where a large part of future career opportunity may come from. So should you consider this career? Ask yourself 3 simple questions. Do you enjoy logical problem solving? Are you comfortable working carefully with technical details? And third, are you interested in protecting the systems behind banking, messaging, cloud service, and digital identity? If your answer is yes, start by learning the fundamentals and completing one small practical project. Now tell me in the comments which direction interests you the most. Your cryptographic research, cryptographic engineering, or PKI and communication security. Now before I go, here's today's 20-second cyber story. In 1586, Mary, Queen of Scots, used coded letters because she believed her message were secret. But Thomas Philpins broke the code and the decoded letters were used as evidence of her involvement in Babington plot. More than 400 years later, the lesson remains the same. Never assume that encrypted means unbreakable. Now, if you found this useful, subscribe to Your Cyberstop and follow the rest of my cybersecurity career option series. And I'll see you in the next video.